Oh, that's my Twitter. Right. Okay. So as usual, there's a couple of links in the chat. One's a fill out form so I can capture the sort of people who are attending. At the end of BGA, probably around the beginning of November time, there will be a bigger feedback form so that we can make some improvements for next year. The second is the Discord. So if there's any big questions that can't get answered during the session, drop them on there and then I will throw Sibeli at it. But yeah, barring that, I'll hit record. And there we go. So, hello everyone. Welcome to session 32 of BGA24. This is our third session on GoaT with Sibeli. Please take it away.
Hi, everybody. Thank you for joining the session. Let me share my screen. Hope you can see the GoaT already. Yep. And slide. Yes. Okay. So if for some reason my video doesn't run anymore, I think we'll have to stop and I'll have to reopen things just so you know. But yeah. Welcome everybody. This is the second session on Genomes of the Tree about how to query sequencing projects on the GoaT web for especially EBP projects. So these are the sessions that happened already. So we have a quick overview of what GoaT is that happened at the IT and infrastructure, the EBP IT and Informatics Standards Workshop on October 15. It is recorded and it will be in the BG24 BGA Academy YouTube channel. We also had another one that is a more in-depth introduction on the GoaT UI, the GoaT web, and how to use what buttons you can see, where you can click, but directed to the actual genome metadata, so genome size, chromosome number, haploid number, etc. And then yesterday and today, we have two similar sessions. They are focused on the UI, but in the perspective of let's say a project manager or someone that is interested in querying the data that relates to this project. So plan, progress, and what is done. Before I start, I just want to say that GoaT team, extended team, is formed by a lot of people. Rick Chalice is the person coding GoaT from start. I am just the curator. We have Fang now that is helping me with the data. We have Max that is the developer for the GoaT command line interface. Mark Blackster that is the person that envisioned GoaT. And Matteo Mufato and Green. They are both here at Sanger as the IT and informatic infrastructure, so they are helping doing the GoaT deployment. And as a spoil alert here, we have Deep Nayak, that's the person that was a collaborator for Google Summer of Code, and he was working on creating a natural language interface for GoaT, so you can query terms using just human language, yes. Yeah, so I'm not going to go over into too many details. So if you have any questions while I'm speaking, please interrupt and I can take them as they arise. I think it's easier that way. And let's start again with what is GoaT. So GoaT is a database, but it's a lot more than that. So GoaT is a data aggregator, which means it is not the primary source of the data, but it tries to get information from all of the specialized sources to collate them in a single place. So anything that is relevant for genome sequencing, you should be able to find in GoaT. And that includes not only metadata for the genome, like genome size, chromosome number, ploidy, but also legislation, list of species that are planned for sequencing by a project. So everything is grouped together in a way that you can, from planning all the way to completion, find metadata about sequencing projects, right? And of course, because it collates, it tries to be a centralizer place, it gets to help coordination, definition, and also tracking of these projects. You can get more information on how GoaT is deployed here in our GoaT first, the manuscript, the description. And here is a background of how GoaT works behind the scenes. So it is a data system, and it's pretty much a powerful API built on top of Elasticsearch, which means that GoaT is not a relational database. It's a bit different the way that the queries are made, but it allows GoaT to be very powerful. So any of the attributes can be queried against any other. So there is no dependency for what you find, and you can also retrieve every single observation as well as summary values. And because of that, it has its kind of complex query language. And this thing behind the scenes is what coordinates what we see, both in the web UI interface and the command line interface. So we built the GoaT UI or the GoaT web that you can access in this link, just as a type of window for users to have an idea of the capabilities and all the functionalities of the API, right? So there is a way to query using the same language that the API is accepting on the UI. And anything that you get on the API, most of the things, I guess, most of the things that you can get with the API, you can see on the UI in form of lists or in forms of pages. And the part that is interesting is that the API generates a link. And that link is how you retrieve the information in a computer readable format. But you can, if you look at the GoaT UI and you do the query that is similar to the API, they will have the same link. And that link is persistent. And at any time, and every time you click on that link, the information is maintained, let's say, live. That query will happen again. So if you go to the UI and you get this, all the family representatives of at the level of species for the entry of life, that's what this acronym means, you get a link. If you add API version 2, that's the version we are now, you get the computer readable format for it. So it's really nice because it's interchangeable and you can just use the UI to see what you would retrieve in bulk with the API. And as the same happens with the reports. So we have some types of reports, they are the most used ones, just to allow for data exploration. So if you do a query, you want to see a little bit of how the data interacts before you really download it all when you perform your favorite analysis. There are some options of plots that you can do just to see how the data behaves before you actually do your analysis, right? Of course, you can use directly the plots from GoaT anywhere. But yeah, and then the other side of GoaT is that GoaT is a window for sequencing projects, especially the projects that are affiliated with the Earth Biogenome Project. And what it does is it collates a bunch of project pages with the most common reports requested by the projects. It's a bit standardized at the beginning, but then any of the reports that GoaT can provide can be added to those pages. But it's a place where people can go and check what the project is, the responsibles for the project's contact information, everything. There is a general information about her sequencing project. So yeah, in the end, now instead of going, every single project I think will have their own, go back a bit, their own project page or database or a centralized, a data warehouse. But what GoaT does is collate the information of all of these different projects. EBP right now has around, I think, either 48 or 52 projects, and almost all of them are on GoaT. And imagine that if you had to go in every single one of the portals to retrieve information. What GoaT does is just get all of the metadata, all of the target lists, and put in a single place. So, okay, I'm shifting gears a little bit to talk about some of the terms or some things that are a bit confusing for some of the users. And I want to make clear here that I want to talk about GoaT can do a lot, and GoaT store a lot of data, and GoaT also have estimates for the data that it stores. So first of all, I'll show what types of data are collated from specialized sources, right? So GoaT has direct values, and this is related to DON sequencing. So things that have data in specialized repositories. If it is a genome, it will be, of course, in one of the assembly databases. So the sequencing repositories themselves, like mainly INSTC, which is the NCBI, NA, and then the database of Japan, but also collates other, the public assembly metadata from other repositories as well, such as the China National Gene Bank and JGI. And these data, of course, if it is on one of these databases, it means that the sequencing is done. So all of the metadata from done things. The other type of metadata that we get is from analysis from these done assemblies. So that's in Blob Toolkit, for instance, we can get assembly, the N50, scaffold N50, contig N50, number of genes, if it has been annotated or not, if there is RNA sequencing for the species. All of this can be found there. And this is retrieved from either one of the assembly databases, but also analysis database pages, like Blob Toolkits, or even directly from the data portal of individual projects. And then finally, there is the specialized databases, and these are the ones that sometimes generate confusion because they are from everywhere we could find information. So these are the karyotype databases, animal genome size, tree of sex, and they collate every information that we can find on the species. We attach this information to the taxon, and GoaT also does estimates on top of them. So this is the part that is a bit tricky and generates a bit of confusion, is that the types of data that GoaT have, okay, we have all of the direct values, but we also have estimates. And this is to account for the bias in pretty much availability, right, of this type of data out there. We have a lot of data on vertebrates, for instance, and almost nothing on some of the invertebrates and marine taxa, for instance. But let's see how GoaT does it. You can find it in detail in the first presentation. There is a link to the first GoaT session, so you can see exactly how it happens. But imagine that there are observed values, in this case, that's genome size, that GoaT goes and attaches to the taxon name, usually to the species. It computes using a summary estimates to the most recent common ancestor with the taxa that don't have any data. And it goes back the tree, computing summaries that are all estimates based on values that you can observe. And because closely related taxa usually have similar numbers, of course, that's not always, GoaT brings back that and fills up the values with the value from the node with the most recent common ancestor that had direct observation. So in this case, for instance, this species here, color-coded in red, also in GoaT, color-coded in red, will receive an estimate from its most close ancestor. This can be two species with the same genus, and then it receives the genus summary value, but it can also be these two genera, one with data and one without, receiving the family instead here. And then the other misconception sometimes we have on GoaT-UI and what type of data it has is the difference between the metadata that is attached to, comes from DOM sequencing, like from the sequencing repositories, versus data coming from the projects themselves, so the project lists. These are lists of species where they have plan and they display progress. This is a list that I usually request from the projects with controlled vocabulary. So we have the taxon, we have mainly two columns saying first what type of target it is. It is a priority, it is not, it's just on the wish list. And the second one is the sequencing status, which goes from sample available all the way to genome node published. And then they can live update that spreadsheet, or if they can do that in their own portal, also GoaT is accepting that. And every single day, at least weekdays, GoaT is gonna update that information. So if you decide you're managing a project and you decide to exclude some taxa, let's say all of these right here from your list today, GoaT tomorrow will not display those taxa anymore because it syncs with your file. And that's it. So the data itself is attached to different indexes. And that's just a way to say that there are different ways that you can look at the data. So mostly we use the taxon and the assembly indices. The samples is actually in progress as a feature. But for taxon attributes, you get every information that is coming from all of those different sources will be linked to a taxon at the level of species. Most of the cases, species, sometimes subspecies. But we'll have all of the direct values tagged to species, and then we'll have estimates going up and down the tree from those values for other taxon ranks. For the assembly attributes, we don't have summaries. It's another index where you can see each assembly and every single data associated with it. In our YouTube channel, you have a short video just with a demo showing how to retrieve and how to query those different indices and see what types of columns there are. They are different. So you can actually turn this on the GoaT page, the help page. If you click on, I'll give the slideshow for everyone. So there is the link there where when you click on this button, you can untoggle a list of all of the attributes, what they mean, how they are summarized, and a brief description of what they are. So you can see all of the columns that are possible in GoaT by clicking on this one. All right, I think this is the introduction. So now we're gonna go to the part that is more hands-on. So if I want to show you where is the chat? So this is the hands-on portion of this session. If everybody goes to the GoaT-UI, you can click on the link directly in the presentation that I shared. It will take you to the landing page of GoaT. Yes.
I think we need access for the doc.
Great. Thought that I had shared with the same. It does whatever it wants. You have to respect it. Share. Can you open it now?
Can, thank you very much.
Awesome. So this main link here takes you to the GoaT-UI. So that's the main page, this guy here. I'm gonna make it a bit larger for you to see. As I showed in the other tutorials also, what I usually like doing, and then I think that's what I'm gonna be doing from now on, is I split the screen. If I have two screens, I use one for each, but in this case, since I'm sharing, I'm keeping the instructions to one side and then GoaT page to side by side. So you can already start interacting with the page. What I want you to see is just a subset of the main things that I have on the landing page. So these are all clickable: search, the help, project, sources, and they expand with more information about each type of tab. But today, what we're going to explore more than what we did on session 1 is the main page, the main landing button page, that when you click, it restores GoaT mainland. It doesn't matter where you are. Let's say that you are here, you click on the GoaT, it will take you to the landing page again. So if anything goes wrong, what you can do is just go back to the landing page and then copy paste and open a new session for GoaT. I think that's more, it's easier to do because GoaT has a cache system that it's keeping whatever you have selected previously. So if you had selected a subset of columns and you were doing something and then you break something, for GoaT to go back to 0, it's best just to either create a new Go tab or just click here. Otherwise, it will still be trying to find what you were trying to do before. Then we will explore the projects tab. And you'll see there is a page dedicated for EBP, one for the affiliates, and then one for all of the projects, which includes some of the projects that are not fully available on INSDC, but they might have some data in JGI and China GenBank. And then finally, there is the cogwheel here. That's user settings. We'll go over this a bit later as well. But here it is. So yeah. If you scroll down, all the way down the page, actually, I'll go to the landing page first. If you scroll all the way down, you'll see that you can see you can pick a color palette to change how you see GoaT. So if you have any, so if you need colorblind friendly palettes, you can choose the best one for you. And I think for now, that's it. So as you can see, if you start hovering over the page, you start to see these tooltips showing up. And they usually happens throughout everything you do on GoaT. And it's really nice to give you more information about what you're looking at, either what attribute name or a column name means, or a result means, or a link out to somewhere, right? So you can always hover whenever a little hand shows up, you can just click and see what it's trying to show you, especially the data. For the project pages, we have, let me get into one of the EBP affiliates. I like that one, okay. So usually what we have is the name of the project here with a logo, a GoaT search term. So each project, they will have a GoaT acronym, short description with link outs to the project main redirection site, the bioproject ID, which is the umbrella bioproject for that project, and a main contact. And this is actually one of the most important parts of the GoaT dedicated page for a project, because it shows who they can contact in case they need to solve duplication or if they need to collaborate. So this is usually the instructed contact for users or for different projects to contact one another. Yeah, so here's exercise 1, and it's to explore a bit of the EBP page. So what you need to do is just go to projects, EBP, and maybe I will give you 5 minutes to just do the instructions of exercise 1 and 2. And then if you have any problems, you can let me know, and I'll do a small demo of what you can see by doing that. I think 5 minutes is enough for both, but let me know if you need more time. think we just hit the 5 minutes. I don't know if anyone needs more time. If you need more time, just actually thumbs down. I think it should be okay to start doing the demo.
Should I put on timers for you?
Yes. I've been writing down, but I calculated somehow that 5 minutes would stop at 7:03, and then
Okay,
so
I'll put timers on. We get a fun little jingle at the end of it.
Okay, so let's go over the instructions. The first part was hover over the reports. I kind of had done that already. So if you hover over the reports, of course you have to be on the page. You can see already the different numbers of values for whatever the report is telling you. So in this case here, it's every taxon that has been sequenced under the Earth Biogenome Project umbrella already. Here we have the tree where you can expand the taxa that it's displaying. We have the scatters, the histograms, where you can click. If you click on the bins, it will take you to the result corresponding to that bin. So usually what I first do when I'm interacting with one report is to open using the arrow right beside it. So that's a trick for every single report, including the trees. This is for the EBP ARC report, so the rainbow report showing what has been done per taxonomic rank. When you click to open the full report, you'll see a little bit of what the rainbow is trying, or the report is trying to tell you. And then there are many things that you can do to edit this and see. Say, if you really like big letters, you can change point side. I always encourage people just to break everything, just hit the button, see what they do. If they don't do anything, just hit the back on your browser. But for instance, here, what we're seeing is assembly span and bioproject information. So what this link is showing us is every single taxon that has a bioproject of under the EBP umbrella. That's the code for EBP bioproject. And this is actually unnecessary, but before, when we first started displaying this type of arcs, we needed to say that it has an assembly span as a proxy for it has an assembly. Nowadays, what we do is for different queries, you use assembly type because it's a much better, let's say, proxy for having an assembly mounted as a proper assembly. So, yeah. So if you hover over it and pick one of the arcs, it will take you to that result. So for instance, EBP here has 1,060 family species sequenced at the family level. No, families represented in the sequencing. And here we have 3,000 something species out of all of the targets. So this is out of all of the taxa in the NCBI taxonomy. And if you click on it, it will expand. Sometimes you'll go to the bottom of the page and you have to go up, but still, it's everything that has a bioproject under the EBP assembly. Here you'll see all of the bioprojects that are associated with a sample, with a species. So let's say if it has been a Darwin Tree of Life species, you will see the bioproject of Darwin Tree of Life, plus whatever other projects had collaborated to release that assembly. If there isn't many, let me see here. The lowest we got here is 4. You can click on it or hover over them to see it in more detail. But you can see here that for at least this species, we have all of these bioprojects associated with probably 2 assemblies, and which is actually the case. So for that species, we are summarizing that we have an assembly, at least one assembly. Sorry, I'm going all over the place. You'll see that we have 2 coming from two sources, the values for bioproject. One of them is labeled as the primary value for that species. So usually whenever something has a primary value, it's the one that is going to be displayed on the GoaT tables when you do the search. You can understand a bit better if you click on assembly span. You'll see that there is these values, and it's the primary of 3 direct observations. And these are 3 different assemblies. But yes, so species. Yeah, so this is actually the corresponding query for finding this information. We have assembly span, which is here as a column, and bioproject here as a column. It doesn't always come like that, because when you first start using GoaT, there is a subset of selected tables that you get. And how you get to the columns is actually by clicking on the result column and selecting the ones that apply. I usually recommend selecting the ones that you use on the query. You'll click them for visualization on the table and remove the others. What you can put anything you like on for visualization. The thing that you must be aware of is that each one of these terms, right? Each one of these conditions are true in the table that you are seeing. So if you put here that you also want an assembly type chromosome, then you'll get less results, because you'll be filtering this to also show only a chromosome. Oh yeah, and then now it's how to change to a different index, right? I said that we have taxon and assembly, and we can control this part over here. So right now we are seeing the summary of all of these information per species. That's the tax rank that we chose. But what if I want to see all of this information assembly per assembly? You can just click here to change the index. Assembly will show up, and then you click on the search again, and it should update to show you the equivalent. Sometimes it will not show all of the columns, because we have some columns that are specific for taxon and others that are specific for assembly. But usually it will be corresponding with the conditions that you put up here. So there you go. Did you get to do the number 2? So this is a demo of the second exercise with the instructions. Instead of opening up the rainbow, I'm going to open up the tree. And okay, it's a huge tree, but the main point here is that you can just hold and click on any of the taxa, and it'll take you to that branch, to the results of that taxon rank from the tree. So the tree of the Earth Biogenome Project is showing every single order that has at least one individual sequence under the bioproject umbrella. And it's coming from descendants because it has at least one species sequenced. So it's always, how to say, summarized in orange, because it's a value coming from a descendant species. But if you keep clicking and going, it will take you all the way to species level. And at the rate that you're doing this, the main search box, search results is also updating. So you can use the trees to start exploring the data as well. Thing that is different is that if you click and hold, you keep going on the tree, or you can always hit here to go back to a parent taxa. But if you just click once, you get taken to the records page, which gives you, imagine, a summary of everything you can think of for that taxon. Everything that GoaT stores for that taxon. And the search is pretty simple. So whenever you do a search on GoaT, if you open a new GoaT here, if you just want to see all the information GoaT has for one species, you can just go to the GoaT website and paste the name of that species. It will update sometimes suggest the spelling if it's wrong, but it will take you to the search result, the table, and when you click on the name of the species, that takes you to the species page. And there are some banners on let's say stamps for the species records saying whenever what is the sequencing status, the further sequencing status the species has been. It has link outs to whoever has what sources we have data for the species. Some summary statistics here, the lineage, anyways, distributed by every single group of attributes that we have on GoaT. And as you can see here, this is the taxon, right? If you want to see the same thing for the assembly, you can just select that you want assembly, or sorry, it didn't go there, but it usually does. Or you can click on an assembly. Let me see. So it says here, assembly level scaffold, and it's coming from two direct values. There are two places you can go to see assemblies. So let's try the second one that is saying that's the primary assembly. And it takes you to the assembly page now, where all of the summaries are about that specific assembly. So in that case, for the assembly, now we have assembly span is this. It means it's attached to the assembly identifier. So it's not a summary anymore. That value is tagged to the index assembly. All right. The exercise 2 had this additional exploring, just to show, the main point was to show the difference between a project page for an umbrella, like the EBP, that will have mostly all of the reports made by the bioproject, using bioproject ID as a proxy for sequenced by that project. But with the EBP affiliates, when you see some of the reports are not about assembly. Actually, most of the reports are at the taxon level, and they are not only about things that have been done. For instance, here in the rainbow, we have things that are under the bioproject of Darwin Tree of Life, but some of the other reports that say sequencing status, they are summarizing all of the information that the project has been given to GoaT. So here's some of the definitions for what those status mean, but you can generate and play with the plots. Let's say right now, this is a plot of, at the moment, how many taxa are in progress. But there is another report that will show you how many taxa have been in progress throughout. It has been in progress by DTOL at some point. So there are slight differences depending on what you want to see in the results. I know it takes a bit to get used to the glossary of those terms, but the idea of these project pages is also to show you that there are different things you can get based on what attributes you're using. So there is this area of duplication checkers. If you click on them, it takes you exactly to the result of that search, because the syntax is a bit more complex. But you can see here that you have 552 species that have some form of duplication according to that report where I clicked. So there you go. If you are responsible for a project and you want additional things shown in your project page, there is always the custom report part of the GoaT pages. And then, for instance, here we have the contiguity assessment of assemblies. So these two plots are equivalent. They both correspond to all of the assemblies that have been released by Darwin Tree of Life. But one is highlighting whatever is a primary assembly versus the alternate pseudohaplotype. And also the same assemblies labeled in categories like chromosome level or scaffold level. And you can see like the scaffold level ones are usually the alternate pseudohaplotypes. and you can play with these plots as well. So I know it's scary, but you can get to these reports directly from the project page by clicking. The less complex ones you can actually try to get yourself until you get to the point that you can generate these as well. It just takes a little time, but I encourage people to play with those. So point in time is here. You can select the full block and see all of the assemblies that correspond to that bin. So this is a contig N50 versus scaffold N50, just showing basic contiguity starts, and you can get to those assemblies. If you want to see just a single one, you can actually shift to point and click on it, and it takes you exactly to what that assembly is. So you can get more information about the data points in those reports as well. I'm giving a lot more detail today than I did yesterday. So if you think this is too much, you can also stop me, or you can try just to push through and then see the section 1 that is a lot more general than what I'm doing here. So these exercises, they had one specific goal, but now I'm going beyond, I guess, what it was expected. So before we do exercise 2, these are misconceptions, also generating misconceptions for some users. So I wanted to clarify the glossary of all of the terms that you can use to try to find out the target lists and the status of the species they are under sequencing. So here are the 3 terms that we use to label a project target. Long list is the wish list of a project. It doesn't mean that they all will be sequenced, all of the species. It means that these are all of the species within the scope of a project. They are considered also potential targets, right? And then whenever we do the overlap report of long list, what you're seeing is mainly the overlap of scope between projects. So the entire list of a bat genome project will be inside the vertebrates genome project, which will be split between several projects. They are regional. For instance, all bats of Canada probably are targeted by the Canadian biogenome project. So there will be a lot of scope overlaps, and this was intended to show to the projects lists of species that they can start negotiating or kind of resolve duplication or collaborations. So, sorry. And then other priority should be the list, the tags that you give the species when they are more likely to be sequenced. So you have real plans of sequencing. And family representatives, they are a special case of this type of priority because some of the projects, they do have phases where they have family representative, genus representative, until they sequence the entire fauna or flora or eukaryotes of a region or a clade. And then one thing that I get a lot is that, okay, for the smaller projects, this is kind of excluding everyone else from trying to sequence a species. And I want to say that, no, this type of tag for the species is not a form of dibs. It is just a form of disclosing what are the possible targets of a massive project like Darwin Tree of Life or any other project associated with the Earth Biogenome Project. So then other small labs and other projects can actually get in contact. Remember that I showed the contact page for each project and try to establish collaborations, resolve duplication. Especially, it was interesting at the beginning because the family representatives for the Darwin Tree of Life were actually selected based on, okay, these are the more urgent that we need to sequence because that's the first phase of the project. It would be nice if someone is already doing it and let us know because then we can use the resource to do another one. So this is the intended use of this attribute. And then we have the sequencing status. So, oh yeah, here in the target list, whenever you do a query, you do long list equals the project acronym. All of the project acronyms are here listed in when you click on projects. In this case, sequencing status can be equal or tagged to one of these values here, and it's going to show progress over time. There is always one including the other. So for instance, I can do, give me all of the species by a project that is in a stage earlier than in progress, or earlier or equal to data generation. GoaT can do, take the higher than, less than, equal to type of commands. So sequencing status is the furthest sequence stage reached for a taxon across all of the projects. It doesn't care if one is sequencing, if the other one has collected. It will always show in sequencing for that taxon. But to allow users to explore the sequencing status of a specific project, then we have these columns. They are the sequencing status underscore project acronym, because then you can see across all of the projects, one per column, who is doing what. So it depends on what you are trying to see, but then these are the values that you will see under these two attributes. So sample available, there is a sample identified somewhere. Sample collected, it has been collected by the project. Sample acquired is it has been received by the sequencing center, which is going to be doing the lab work. Data generation and in assembly, sometimes they appear separately, sometimes they appear as in progress. But in progress is the sum of data generation and in assembly whenever the project can give us more detailed information. Some projects cannot, so they just put in progress and then we report it as that. So that's also why you see some of the histograms that show progress. They will have, sometimes they will have these two, sometimes they will have only this. And this goes from the sample is in the lab, so data generation, all the way into in assembly, that's the in silico part. So all the way until the assembly is submitted. Once it gets submitted, then we move to open, which is, it is openly available for, even if it's for like in a bucket type of warehouse, right? So data storage places, Zenodo, any place where people can actually go and see the assembly, so the files for the assembly. It includes also everything on INSDC. If it's already visible in INSDC, it's also open. But one level extra, so we know it is on INSDC, so GenBank and ENA, NTBI and ENA, it's this tag here. And this is usually what we want to reach, because that's easier to do the counts and then to link the results to the bio project of the Earth Biogenome project. And finally, we have the status published. That means it's not only open, but also there is a publication showing that genome. So does anybody have any questions so far? All right.
I like this explanation. Perfect.
Oh, thank you. But you can see that this is progress over time, because it is one column that can have any of these values, right? But when you go to the column itself separately, so it will be a specific status called sample available, and that's going to be its own column. Then this is time agnostic. It doesn't care if that's the furthest along that a project have. If I put sample available equals the project acronym, it will retrieve all of the species in a list of species where they flagged at some point that sample was available. And this is useful whenever you have other types of goals of search. So there is a lot of confusion about it, but usually if you want to know how far a project went, or all of the projects went, you go to one of the sequencing status. Every time that you want to know, has this ever happened for a project, or give me a list of projects where these conditions are met, then you can use the individual ones. So usually I select, let's say, sample collected or sample available. columns to see all of the projects that have collected or have identified that there is a sample available that I have interest. So it means, okay, it has been collected. Then I check if it's in progress, what is the final status for those projects. But if I do sample collected equals just sample collected, I can get a list of everything that has been collected, and maybe one of them are the species that I want to sequence. I can contact them and then maybe foster a collaboration. So these are just examples, like I said, of the use cases, but yeah. Okay, so now we're ready for the next batch of exercises. How far are we? So it will be 1 hour? Yes. I think we do these exercises, we take a break, and then we go back. So this is just a sheet for the search box of GoaT. That's what you find in the landing page on top. This is where you type stuff, and usually you get stuff back. Sometimes it misbehaves, but don't blame the machine. Sometimes it's it's human or the GoaT. So if you any time you have any questions about what you can do in the box, let me know, because all of this explanation is actually from session 1. There's here the link for the video tutorial. If you have time, just try to go. But it's not that hard to start using making the searches using the query builder when you don't know what is in there. Right? You have a box, you have no other information. This query builder will help you at least get started. If you just want to know everything there is for one species or a taxon, just feel free to click here and enter. If you need to do more, usually do query builder and something. Click drop down and pick options. So yeah, how can I find all of the targets for a specific project, right? Yeah, let's go with this one. This you feel free to just do alongside me. So if you go to the GoaT page first, wait for it to load. I'll make my screen a bit bigger. I'm in a different screen. Okay, so as I said, all of the wish list for project, we are using the long list attribute on GoaT. And then let's say that I want to see the project Erga Switzerland. Of course, you don't need to know all of the acronyms of the projects up front. You can always have a second tab open on the projects, and you'll see, let's wait for it to load. Yeah. Sorry, it takes longer when we are in the Zoom. Okay, you'll see that for every one of them, you'll have the acronym that GoaT uses, the name of the project, and then the bio project. So I usually keep this open as a cheat sheet separately, additional browser, because then I don't have to go to ENA and try to find it. So here, long list, and then select the project that you prefer. I like the Erga Switzerland because it's not that big of a list, and there is stuff already in progress, so it's nice to see. And always try to get the tax rank, because otherwise you'll get everything, all of the taxon levels possible. So tax rank, species, I usually do it directly on the search box because I'm used to the terms. But if you are not, you can always do this. Let me copy this. You can always do this using the query builder. I'm not going to do that yet, but I'll show you how. And then you click on taxon, include descendants. Oh, I forgot the next. Yes. So now you have a list of all of the taxa targeted by that project. But you'll see that there is a bunch of columns that I don't care about. Maybe I do, but these are the default columns for GoaT. If you're just interested in status, you can just go to the results columns button here, and then you select what you want to display. So I like displaying the assembly level because it shows me if a species has been sequenced or not as a proxy of, yes, it has an assembly, it's assembly level. Assembly span, I don't like so much because I'm not using it for anything now. I don't care about those yet. I care really about the projects. So let's see if it's in the long list, the family representative or the priority. And then sequencing status, I want to see sequencing status. Since I'm doing ERGA Switzerland, I'm gonna try to find here the ERGA Switzerland sequencing status specific. And again, you can always hover over and see what GoaT is trying to say. And then, yeah, it's getting larger, but we might do something about it. And then I want to see if samples are available, right? Sample available, sample collected. And then I think that's it. That's all I need for now. And you see that you can just click update, and then it will recreate the table for you, meeting these conditions still, but now showing all of the fields that you have interest in looking. So if you're following along and clicking, I hope that you got here. If not, just do a thumbs down and I can wait a little longer. But yeah, so now you have this list. I didn't need to put all of these columns. I could just get the long list column. But you see there are 40 hits. And then here I can see that there is the sequencing status and the sequencing status that is specific for ERGA Switzerland, right? Sometimes one comes from the other. So the sequencing status is really just coming from Switzerland, but hopefully I'll find one that is different. Yeah, this is one of the projects that are really active solving duplication. So whatever is in progress by them. But you'll see here that in the long list, we have an overlap of ERGA and Psyche. So in this case specifically, Psyche is a project that targets only butterflies. ERGA Switzerland will have butterflies. And most, how to say, it is highly likely that they are already collaborating. They did collaborate to generate this sample. So that's the thing. You can use this or this column just to try to see if really you need to contact them or not. So see, this species is in the long list for both. But then if you go down, you'll see that in the other priority, we only have Switzerland here, saying that they really want to sequence the species, except for this one. So then maybe they could contact Psyche to see if they have it in progress, if they want to collaborate, if they haven't done so yet. So that's the type of uses that you can have by just clicking and seeing across columns what is going on. If you really want to retrieve a list that is showing only whenever there is duplication, you can try to use some of the operators of GoaT. For new users, I think I suggest best to use the query builder. So you see that the query builder does is that it doesn't care about, you can here put eukaryota, but if you don't put anything, it directs to eukaryotes. Add the rank of species, and then the value was long list equals ERGA Switzerland. What you can do to refine your search, then you make more conditions to be true across your results is, so let's say assembly level, right? So if you do assembly level now, you are looking for everything that is in the long list of Switzerland that has an assembly level. And then you can even refine that by equals, oops. And then, of course, the values you can get by exploring the drop downs that I showed you at the beginning. Until you get there, they are pretty much the same as NCBI data sets. So for assembly level, we usually have chromosome, contiguen assembly, and complete genome. So chromosome, and then if we hit search, you get a much smaller list because now all of these conditions have been met. And then, okay, that's the perfect search that I wanted. I can add to favorites. And what this does is it saves second query window. It's clicking on the query builder. This one you mean, right? Yeah, so right under the search box, if you just arrived on GoaT and you click here, you'll see all of this not filled. If you just type the name of the species and you open this query builder again, you'll see the name of the taxon here. But you can set at which rank you want to see. Of course, if it's anything but species, you need to put here to include estimates. Otherwise, you won't be able to see the taxon because you cannot put all of the frogs at the level of genus and not include the estimates because all of the data is coming from the species. And then here, you can always select the value. Then these are all of the possible columns that you can pick pretty much, but these are the search terms. And then they're split into the different subcategories. Oh my God. So everything is pretty much here. So you can explore this part much better. And then the operators can be all of those. So for the attributes that we have some kind of progress, let's say I could do assembly level greater than scaffold and still get the chromosome ones because it will show, let's do this one, greater or equal than scaffold, because there is a hierarchy for that type of assembly. So when you hit search here, it updates, well, there isn't any of the, that meet this criteria and it's equal or greater than scaffold, but you could retrieve it. And if you do, I mean, just double check, it doesn't have any scaffold only. And if I hit greater than scaffold, it should show me only chromosome. Yeah, here. Okay, so what I was trying to show now, okay, if I hit search the favorites, then it gets saved for you. And then next time that you open GoaT, you are able to click up here. So then, of course, this one won't have it yet because it was open before. But next time that you will use the same computer, same browser to use GoaT, then you click on search settings and there it is. Oh, no, there it is. Sorry, I have too many. And then if you expand this, so I expanded only this one, and you'll see that the result is at the level of taxon. The options are the indexes. So it can be assembly, taxon, include estimates. I put through because I always like to put through because it retrieves everything under that rank. The size of the table that you get, it can vary. It can be 10, 25, 100. I think the max is 200. I'm not really sure. And then all of the columns that you selected, and then the actual terms for the query. So you can either generate a QR code to share with people, let's say for a presentation, if people want to follow along and see where you got the data from, or you can edit, let's say, I don't want the size to be 25 anymore. I want it to be 100, no, 10, because then I don't see a lot of stuff. When you do this, actually what you have to do is click on edit again and then save changes, otherwise it's not going to get picked up. But there you go. Or you can just hit search and it will take you to your query. So this is the new tab that I had open. The other one is here. And because we only have three results, that you cannot see the difference in the size of the table. You just have to believe me. And okay, that was pretty much the exercise 3 completely. Yep. Do you need time to do that again? This is the cheat sheet for it again. Okay, I'll do what I did last time. I will just show you the other ways to explore the search results in the table. And then we take a quick break and then we come back, I think. Yeah, there is a lot more of these in the slides for the first session. If you get that one, then you have detailed step by step. And then on the GoaT YouTube channel, I'll paste the link for you here. I am creating a playlist that is just GoaT answering a single question, so it doesn't get too overwhelmed for the users. So if you go here to playlists, and then go to screen recordings, so far we only have a few, but it usually follows the format of a question and then a quick explanation with the steps that you'll see. And it's just a recording. So I will give you the link for it's actually in the presentation tool, all the way up. Well, there you go. It's @genomezoom3. There it is. And then if you have ideas of questions that you want to answer, just send it to us, because it would be really nice to get specific questions where if someone else actually asks them, I can send them the video. So it's easier for them to follow. Okay. So subset columns. Who is this? You can click on the link if you are following using the slides. So this is going to take you to that table that I was showing. Maybe it won't. So let me see who it is. Okay. What I did here was just look for taxon. This time you'll see here is tax 3 candidate, because I'm doing the search at the family level, but I also want to see as the results each species. So this is giving me all of the candidate at the level of species here in the scientific name. So we have 74. And then can you see here that we have a lot of stuff for chromosome number? When we do this query, the same query in a normal, what is this? In a new browser, what you actually see is all of the, well, if you didn't save, you'll see all of those, but you see that chromosome number, it's alone here. And this show height subset columns actually gives you the distinction of what is going on here with direct, the estimates. So you can see here and expand this column using here subset. If you click on the drop down, all of this will take you to an expanded version of that attribute. So now chromosome number becomes ancestor direct, blah, 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 blah. All of this that you can see in the link that I gave you. And this is really important because whenever you hit the download button, so here is the download for the table, usually what you get, if it was only the column for chromosome number, you miss the information about what is direct and what is estimate, right? And sometimes you don't want to care about estimates because you're studying a taxon that is very, doesn't have a lot of information. So if you don't really need the estimates, you can just download this column instead that shows all of the species that do have a direct value. And you can see here that even with the direct value, sometimes we have different different values here because it has been reported, variation has been reported. So these columns now are showing the minimal value ever reported, the maximum value ever reported, the mode for all of the observed chromosome counts for this species, and go on, right? The median height, the mode, and the length. You can then choose what is the best representative of these columns to show what you need. But as you can see, there is a min and max for this case here with 48 and 50, also for here. Why is that, right? So if you click on the chromosome number direct or the chromosome number itself, you can explore a little better. You'll see that for this species, the chromosome number value is the 38 because it's the mode. So it's a summary. It's a mode of two direct values. They are 38 and 78. And it's picking in this case because there is only two, we had to pick one. For haploid number, I know that I put the mode low as the one that it should pick up in case there are polyploids in the taxa. But here it is, and then this can link out to the original source where I got the data from. So I don't know why this happened, but that's the idea too. So GoaT is not there to be the source of truth. GoaT is there to show you what has ever been done for that taxon. And then the users have the power to make the decision. What the users can do is that whenever they identify a really value that is really wrong, is just contact us, tell us that this is wrong, this is the right one, you have both or you only have one. Here's a source for the correct value, and I can label this as primary. Because if I label this as primary, whenever you do chromosome number for this species, the primary is going to be the one that is displayed on the table. So then you don't need really to investigate all of those. It will show here the right one if it's not already. I think I'm getting ahead of myself again. I just like giving a lot of information. And then there is a way for you to see, I want to say with human eyes, the subset of columns for descriptive data. Sometimes you actually just don't know what are the possible values for something. And you can just come here and say, show me everything that has a biosample. And you can see a list of all of the species and then all of the categories or all of the possible results with dots on where that result was found. Of course, for biosample, that's not that informative. But if you want just to have a quick look like this on the what has been sequenced and what level, you can get a visualization directly on the browser of who has chromosome, who's not. You can even take a picture. It's nice to see the dots. That's it. Or even whenever you have this massive type of table that in progress, all of it, this is a link. These are all of the species that are in progress in GoaT. Help. So what I did was click on this link here for the subset columns, okay? Why? We have a rogue. And it opened this one. So this is all of the species that are present in any long list of anyone that has a sequencing status overall that is less than INSDC open, and that the size of the column in progress is greater than 1. You see what I did here? So we can start doing things very complex. And then that the assembly level equals null. So it will show me things that have a sequencing status. It will show me things where there is more than one person working on it. And it will show me things also that don't have an assembly yet. So this is a list of everything that doesn't have an assembly that is in progress by one or more, by 2 or more projects. Well, but who is actually doing that, right? Here in each one of those, you have if you expand, you can see and get directed to their project pages. But I was just wanted to have an idea of how massive the duplications are, how many projects are overlapping. You just click here on the toggle split column, and then now in progress became all possible projects. And then you can actually check duplications by cross-referencing by looking at the rows instead of the columns. That is just to give you an idea, right? Quick visualization of a feature. Okay. This is more straightforward. So we do this one and then we pause for a little bit. This is just to show you how the different ways that you can save the files. Maybe I should just do this also along with you. So the link you saved is ready to use again. So every time that you open a new GoaT, you will be able to see. So here's all my saved ones for taxon. For assembly, I think I only have a few. So I have this genus of bat and any assembly level different than scaffold. So I want to capture the config and the chromosome. If I hit search, I get to my search results, and that's it. So when I want to save, if I want to save this table, all I have to do is click on the TSV. It will give me a tab, separated file. But sometimes it's this type of file, it can be opened directly on Excel as well, but some people prefer CSV. So the way to do that is you click on the drop down here, you select what format you want the data. And then you click again, now it updated here, you have to click again on the arrow and it will download the file for you. So this one, because it's CSV, it's set to open directly for me on Excel. So you could see exactly this in the file. But let's say that you want something different, you can also get in a JSON format. I don't know why you would want that using the UI, but that's also possible. And then if you don't care about clicking buttons, you can update the actual link right after org, and you put the API, and then you put the version 2, and then you hit enter, and you get the JSON. So computer readable that you can use. And then this link here is the one that you use for your curl commands or wget and whatever you use to retrieve data from a link. So this is how to download the CSV. And then to generate the QR code. Remember that I showed you that you can generate the code opening these settings. This is to show the settings, but you can actually scroll all the way down and generate a QR code for the entire page. So if you want to show just the EBP page, you can generate a QR code for it. And it will be really weird. So you cannot have it too small because the link is so big sometimes that it has to create all of this. But as long as you have a good enough size, people can scan with their phones and open. And yeah, does anybody have any questions so far? Do you need more time for anything? Do you have specific things that you wish to do on GoaT that I didn't cover today? It can be anything really. If it's something that you just have like a quick curiosity, I'm fine with it too. That's what we did yesterday. And actually I got a really good question that I struggled, but today I can show it without struggling because I didn't have an audience earlier today when I was trying to do it again.
So I was just looking at Hymenoptera done by Detol again.
Mm-hmm.
What's the difference between having a look at those species in the long list compared to in the bio project? Because the difference is like 100 hits.
Yeah.
But in my head, they're the same thing.
you say in the,
So
what exactly did you do to get there?
I
Is-
have this query. that I've just thrown in the chat.
So, okay. Get a new goal just in case, because this is the first time that I'm querying this. Ah. So this is what you have. Hymenoptera at the level of species. So the first thing you did here is end sequencing status. It means that you are restricting your results to only the species of Hymenoptera that have a sequencing status, right? That's the first thing. So you are removing things that other people have done, things that are not targeted by DTOL. The other thing is you have here long list equal DTOL. So now it not only has to have a sequencing status that would give any Hymenoptera with a sequencing status. Now it's giving you anything that has a sequencing status from the long list of DTOL. But keep in mind that sometimes, and I'll show you with the rainbow later, some projects don't declare as a species in the long list until it's almost ready. So there is the bias that I might be picking up, but you might be missing things because they are not yet in the long list. But for DTOL, usually that's not the case because I sync directly with our tracking system, which right now it's not happening because I need, there is some issue happening, but you get my point. So now you restricted, you added 2 levels of restriction to your search. And then now you're looking for the bio project. What you could do, honestly, just to retrieve everything that has been sequenced by DTOL is just drop all of this. You don't need it. You just need to see what all of the species that have been sequenced by DTOL. So that will give you anything under the bio project ID. So this is a list of things that are done specifically by DTOL. What have I done? Well, work. And
You missed the end
oh,
before the
oops.
bio project.
I deleted. That's what I do. Thank you, Fan. Yay! Voila.
You're welcome.
So you have 145. If you did the one, your query from before, because you are restricting so much the scenarios, where am I?
So it kind of creates like a false positive almost because there's so many restrictions on it.
Yes.
Right.
I don't know what I did now. I ruined everything. Let me just copy again. Yes. So this is what we were doing before. Why?
Yeah, then if you take off the bio project bit, it brings back 220 or something.
Yes, because the final restriction is give me only things that have the bio project ID and it's done. Now you're querying something different. Now you're having all of the species in the Tree of Life long list that have a sequencing status. And also something that you're not necessarily picking up here is that maybe it has a long list in DTOL. It is in the scope list for DTOL, but maybe the sequencing status is coming from another project.
I see. Right.
So
Okay.
what you want to do here is sequencing status underscore DTOL, because then you make sure that you don't, in this case, you don't even need long list DTOL. Because then now you get anything that DTOL is currently working.
Right. Okay. That makes a lot of sense.
And you see here, now we have all of these species. If you put even and sequencing status, let's see what happens. Did I do something wrong? Maybe I didn't. maybe it saved my query. I was expecting this to change. Let's try here. No? Oh, you know what? I think it's because Tree of Life is usually working on things that other people are working also already. Then most like if I was looking for erga, maybe then when I put sequencing status, I would get more because then we have the detail Tree of Life counts.
Right. Okay. That makes a lot of sense.
Oh, I
Thank you very
didn't see.
much.
Stefania, thank you. Oh, she left just when I was about to say bye. Yeah, but does that make sense? So usually what I like doing is just, I do the general. Just give me all species of my taxon of interest. And then if I open the query builder, then it's when I can start refining it, because then I know one by one exactly what I'm getting. So for new users, I suggest always go one, then another, see the results and see if it makes sense. So like the query from yesterday, it was really, so this is my current take on it, right? If you start with country list equals South Africa, you get all of the species that have ever been recorded in South Africa. So there is a record on it on the GBIF page saying this species has been seen in South Africa. It doesn't matter if it was seen in the circus. If someone actually put the entry on GBIF, it's going to be there. So it can be dog, it can be rat, like everything that is domestic will be in this list as well. But then taxonomic species, that's always good to do. And then what I did first when I started this query was assemble level equals null, because I wanted to see, okay, let's go back to nothing here. Let's see if it will go, if I need to open a new tab. Yeah, so here is all of the species, 36,007 something of the species that occur in South Africa. Then if I add assembly level equals null, I'm restricting to these species, but only the ones that don't have any genome. So it decreases a 3,000-ish species already have genomes, probably all by default. Or some invertebrate genome as well. So there is, anyways. And then if you add the next step that, okay, but I would really see the ones that don't have, if there are some assemblies at the config level, it doesn't help because I want to generate a really good genome. I can just put the comma, it means or, and then config, config. And then you hit enter. Now it decreases even more, right? 34,000. Still a lot of species, but then you can remove now and not in a long list, for instance. So you can remove everything that has a long list. Now you have 24. So one by one, you can be limiting your query. And if you don't want to do using the boxes underneath the columns, you can actually have more control of it by using really the query builder. Because then in this case, if you look for, let's see, you can even filter on sex determination. I don't want any polyploids. Boom, it's there. But sequencing status, no, I want the target list. Yes, not other priority, different than wait. Oh, this one is a bit tricky now that I see it, because I don't have an operator for saying not. So target list status is not an attribute per se. Let's see if I can just put this. Now what I'm doing, oh, I can put null, of course. Length of other, no, and value of other priority equals null. Sorry, my head just went to the wrong place. It's the same as above. And then I search. A little bit less. But yeah. So now you have filtered on other priority. If I had put even long list equals null, then we would drop all of these that are targeted by Shopify or someone else. All right. So I guess we reached the same point that we were yesterday. I don't know how people are feeling, if they want to keep going, if they have specific questions that they want to see answered here. Because I have a little bit more information that I pretty much already showed in the other tutorials. It's just showing that you can just type the name of the species and it can take you to its page. And then it'll show all of the information it has on it. But then when you click on an assembly, a session, then it takes you to the assembly records page. It links out to different places. This is all being covered. So I don't know, does anybody have any specific questions other than, maybe I can show a bit with I also went over the reports. So yeah, let me show you the rainbow, because this is a source of also confusion. So if we go to the detail, this is exactly what you asked, Nemo, because here. All of the projects, they will have the rainbow here summarized, right? But see how I made this plot. It is, you can always see how I did the query. If you click on the edit for the report, you'll see how the query was. So this is anything with an assembly span with a bioproject ID of detail. So only this would give you everything that has been sequenced by detail, all of the species. However, what I'm doing here in the Y is restricting out of how many, right? So the Y is out of all of the species that are in the long list of detail, how many have a sequence. So now we have this restriction. I'm not considering the ones that are not on the detail list, but I'm counting out of these, how many have the bioproject ID, how many have been sequenced. So now I have 1.48K. So, well, these many species. And remember, this species, not subspecies and not assemblies, because for assemblies, we then increase a lot the numbers. And there are some that are receiving only another project's bioproject ID for some reason, but you get my point. But okay, so now we have 1482, right? But then if you look at the actual numbers here, let me see. Yeah, here. All of the taxa here is 1486. We are missing just like a couple. How many were there here? 1482. We're missing 4 species, right? 1486. And these 4 are likely species that are not on the long list. So it's something that GoaT will pick up. Usually it's gonna happen because when it enters, if it's sample is collected, so when it enters our system, I have to wait until it's done to actually backfeed it into the long list. Just, it's tricky because before we didn't want to do that. But yeah, there are 4 extra species with the bioproject ID of detail. So this is actually the correct number of species with assembly, but this rainbow is showing the number of species with assembly out of all of the targets. So it's not that the GoaT data is wrong or the GoaT report is wrong, is what you want to see, kind of. So these are the things that are attribute specific that you have to keep in mind. But once you understand how What is the difference between them? There are reports that you can make, and there are reports that you can't, given a set of data. So the best idea for you, if you want, is to get, if you just want to report how many genomes DTOL has, how many species have been sequenced, this is the number you get, you should use. If you want to just show progress, even if there is a little bit of bias, then you choose this one. And then the same happens for the sequencing status. If you want to show the status of the species that are in the long list, you get one type of plot. If you want to show the current status inside the DTOL genome engine, then you need to use the underscore DTOL to pick up that information. Is that clear enough?
Yeah, no, that, and to be fair, that's status plot that you have just above is precisely what I need. I just need to restrict it to Hymenoptera because I'm going to be starting a Hymenoptera group.
This guy?
No,
Or
the further down, the one
this
one to the left.
Wow! Oops.
So essentially make a bar
Yeah.
chart like that with in progress, done, waiting to be done.
Uh-huh. And just to show everybody, it is as simple as just put here tax tree. Hymenoptera. Did I put it's right? Yeah, right? And sequencing status DTOL out of things in the long list of DTOL. Remember that I put this. If I don't, then the shape will be a bit different. But that is your report. And this I need to fix. One more thing to fix. But you see that sample acquired is coming after everything else. I want them in order. All I have to do is come here and I can put them here in order. Do you see sample collected, sample acquired? This is behaving weird, but I can make it obey me again. So it is possible. If you want, you can just download the actual data and then do it in a way that looks a lot better. Sometimes there's like these fat histograms. I don't like them, but I mean, you get my point. Or you just do this. That's what I like to do for screenshots. I make it very tiny because then the bars are really tiny. Oh no, I don't know what I did now. Of course, it's live. Anyways, so
No,
yes,
that's spot on. Thank you very much.
And I think, okay, we have 15 minutes. I don't know if I should keep showing stuff. I don't know if that's going to be too complex for people. What I want to do is to I have a talk already for the duplication checks. And it is on YouTube for GoaT. I might do another one just to try to tackle some of the misconceptions as well. But pretty much for the duplication reports is that we have 4 types of duplication, and not all of them show duplications of concern. That's how I want to put them, right? So in the DTOL page again, where is it? Projects, and let's go with a favorite, that one. So if you scroll down, you'll get to the section of the duplication checkers. This target overlap list. So it's saying that there is 1,000 taxa out of the BAT1K list that actually have duplication. So another project is also targeting. And the reason for that is that most of those actually should be 100%. Because all of the bat species, they are vertebrates, and Vertebrate Genome Project is targeting all of the vertebrates. So when you click here, you'll see that some of the overlap. This is actually overlapping scope instead of just overlap. See, GoaT-EBP pretty much for the entire set of results. Now, another type of overlap that we have. No, don't leave me. Is this guy here. This is a bit more important to look at because out of all of the targets of BAT1K, we have 9 species that have been already sequenced with meeting the metrics that were set by the Earth Biogenome Project. So they are very high quality genomes already. So these are species that BAT1K can go ahead and say, okay, I don't need to sequence those because we already met. Even if it's not part of EBP, we have already genomes. So at least take it out of the priority list if they are, right? This other one is a bit different, is now out of all of the targets, how many are in progress by another affiliate, but haven't been started by BAT1K? So, well, oh, I forgot that there was a question, Karen. Was it just now or before? Okay, for the reports all of the reports can be used, retrieved in the API. All you have to do is you generate the report in the UI, you put those 2 terms on top, and that's the link that you want to use. You don't even have to open the API documentations if you don't want to. But if you do, then feel free to go there and then click around because you can do a lot more stuff than what I show here. Okay, so this is the group of species, right? The list of species that are in progress by another affiliate, but not started by my project. That means I can drop it. I can contact the people that are working on it. I can make a decision. So, and that's another thing that I want to highlight. GoaT is not there just to tell people what to do. GoaT is there to show what is there, and then you make your decision, right? If you're a sequencing project that is focusing on a very set group of species that are endemic to this region, and you really want to sequence those because it's a government thing, and you cannot include and involve other people, there will be many situations where you cannot share your data. Ideally, you should, especially if you are an EBP project, you will. But if you're a particular lab that has some kind of embargo, you can look at this and still keep your species. But maybe what you want to do is go to the contact page and tell people, the other projects, hey, I have to do this species. If you want, and I cannot collaborate, if you want, just use the resources to something else, if you can. Is at least something that is nice to do. I don't know if people want to be wasting time doing that, but I don't think it's a waste of time, especially given the current price of a high quality genome nowadays. Still, it is still expensive. So, okay, sorry, it's personal opinion, but yeah, so there are these, and sometimes there is the case, not for this one, that is just there is overlap, but the scope of the project is different. So we have some projects that are only interested in doing not the high quality genomes. They are kind of legacy projects inside the Earth Biogenome Project network. And there are the other ones that they are contributing to high quality genomes by sequencing a subset, doing a subset of techniques. So there is one project, for instance, that was only interested in generating Hi-C data, but of endangered species or the zoo species. So imagine that that's a full protocol that you don't have to do. You can just save the lab work for the Hi-C of these species if you contact them and the data is already public. I think it's the DNA Zoo that's doing this. Anyways, so. And finally, we have the worst case scenario is that everybody's working and it's in progress on multiple, for multiple projects. So this here is in progress and we have already started as well. And there isn't a a public assembly yet. So this one is, if you are a project manager, that's where you want to go and then check. Because if it is the case of overlap at 1K VGP, no problem at all, because they're all being done by the same sequencing center. There are already agreements in place, right? But if it's another project, okay, Zoonomia, if you are a BAT1K project manager, you know that Zoonomia was actually a pilot for sequencing a bunch of mammals, a bunch of taxa that BAT1K might sequence. So there were bats in the Zoonomia project. So it's up to them saying, okay, do you want to improve the quality of that assembly? We don't, blah, 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 right? And then for the Lover, they are a separate project. I know that they might be in collaboration, but if you are the project manager and you find a project that, oh, this one I had no idea they were doing this is the one to contact, right? Because they already started. They have at least, and here's it. I have at least collected, so equal or greater, and sample collected is greater than 1. The size of the column, it means more than one project. So my own and someone else. And this is the one to contact. So I can just click on the logo, go there, see, who should I contact? This is the information, drop an email. It's not a lot of work for this one, at least. And then you can always keep track. The data is always live. So this is what I had to go over the duplications. And I guess this is where I had marked as the end of the talk. So I think we are right on time. Finally. Oh yeah, I don't want to share. I just want to make it slideshow. Yeah. So at this point, in terms of GoaT team, we are collecting a lot of feedback. And I will be trying to create all of the content of tutorials and then understanding a bit better what the struggles of the people that are using GoaT are. We will be able to make it better. There are things that we cannot do, like the idea of creating the specific sequencing status, for instance. They follow a series of things, but we need to have that column separately to collate everything that has on that specific attribute. So it is confusing, but maybe if we do a better job with the tutorials, then people can understand when or when not to use something. So this is what we need right now. We have either the contact email, it is on the drop down in the main GoaT page, the contact information. But if you want to have more visibility in if we started working on your problem or not, you can create an issue on GitHub. So there are already some templates there, but it's good because it's public. If we start working on it, we'll let you know, and then you can see when it's done and when it's live. You will get a notification. So I think it's the best way to go. And then finally, I wanted to thank everybody that attended, the GoaT team, the extended one. Here's our contact. I was able to get this one from the, the talk yesterday. Thank you so much for seeing so many talks about GoaT. But also, I think it was very important for me to do this because these are a series of videos and tutorials that I can put on the GoaT page as well. That's an amazing way to just spread the word of the GoaT everywhere. And there is a lot of people helping me with this part of user experience. So I want to thank everyone that has contacted me. They are from the Earth Biogenome Project, from the ERGA community. And things are happening a bit slow now, but they are happening. So all of these improvements, I hope that they can be implemented next year. So that's the end of session number 2. Thank you.
Thank you for the very flattering picture. And I'm taking that as a yes, I'll be coming back for BGA25 then.
Of course, yes, always.
Nice. Cool.
All
Right.
right.
Well, thank you everyone for coming. Well, unless you want more questions, if there's any.
Yeah,
Oh,
I just have one. Excellent presentation.
Thank you.
Siberia, I like the part that you implement more for the audience project leaders. So I was thinking maybe I could share this EBP session 1 or session 2 with a list of project leaders. And I was aware that some project leaders are willing to dive more into GoaT. So I think these are very informative, so they can get hands-on.
Yes, that would be really nice. I mean, I think that the first step for any project that wants to be involved with ABP, even if you're a small lab, is to contact them, or if you don't want yet, but you want to have a list on GoaT, there is a way to do it. Still on the works, but following this thing of controlled vocabulary and then live files that we can update every day is the best way to go. And if you don't have a list yet, GoaT can actually retrieve for you all of the taxon IDs with the species name of the taxa even before you have a proper list. So the initial thing can be retrieved. So I think, yeah, fun. I think things are gonna get better and better, and people will be happier about the GoaT.
I'm confident. You did
Yay.
awesome job
Thank you.
to keep the system running. It's not easy.
We're there. We're getting there.
Thanks again,
All
Sibeli.
right. Thank you.
Right. If there's no more questions, let's go to bed. It's getting
Yay.
quite late now.
Yes. Yeah.
It's
Thank you,
8 o'clock.
Damon.
It's past my bedtime anyway.
Thank you,
But
Damon, too.
Bye all.
thank you very much.
See you.
And hopefully we'll see you all next week for some more sessions.